Welcome to your last web development lecture. Can you believe it? Congrats on making it this far. It's a huge accomplishment. Let's try to finish off strong with this last sprint. You're going to get to use everything that you've learned in backend and bring it all together in one project, which will be really cool. So remember that backend is really much more in-depth than what we've been able to cover. So there's still a lot more you can learn on your own if you want to pursue it. One piece of advice I will give at this point is to just take it slow. Don't try to take on all of the different backend topics all at once, because there's a lot of them. And with that being said, you're also probably not going to land your first job as a backend developer, to be honest. You're probably going to get a job as a front-end developer and slowly work your way to the backend if you want to, as you learn more and as you get better. But yeah, just take things slow. Don't try to take it all on at once. I'm still learning new things about the backend even after a decade. So don't expect to be a backend wizard after just a few short months. Just take your time, take each topic individually, take each thing slow, and just kind of slowly work your way through all of the new topics, and you'll be a wizard before you know it. All right, and just a quick reminder, we'll have a quick Q&A at the end of class tonight, if we have time, which we should. So come with any questions you might have. Doesn't have to be about backend, it can just be about anything, what it's like to work in the field, whatever's on your mind. So keep that in mind. With that being said, let's go ahead and get started. For our last time together, we're going to learn a little bit more about one of the most important aspects of development, in my opinion, which is automated testing. Okay, we got a taste of it on Monday with writing those unit tests, writing unit testing for those simple calculator functions. But now we're gonna write some integration tests that are a little bit more complicated. So remind me, what is the difference between unit testing and integration testing? What's the difference between the two? Yeah, Jennifer, that's what happens when you start as a kid. I was on my computer coding when I should have been socializing. What's the difference between unit testing and integration testing? Just in a short sentence. Unit focuses on one thing. Integration focuses on how the parts work together. Good. So if you remember from Monday, unit testing is when we test small pieces of code, things like pure functions, functions that always give the same output if they receive the same input. And integration testing is when we test how functions are working together as a whole. So testing endpoints or middleware stacks or some kind of facet of your system that includes more than one function, right? More than one piece of your system. Tests how your system integrates with itself. So how have we been running these integration tests manually up until now? We've been doing integration testing, but we've been doing it manually. How so? What was the process? Yeah, exactly. By using Postman or Insomnia or whatever you're using to call your endpoints, right? That is a form of integration testing. It's just manual. It's not automated. which means it's slow, it's tedious, it can be really repetitive, as I'm sure you've seen. You know, typing in the endpoints, checking the response data, clicking around in Insomnia, it takes time. So if we wanted to automate this entire process with a test, all we do is we write some code that makes HTTP requests to our endpoints and then asserts against the response data. So we're just essentially calling endpoints like we would with Axios in a React app, but we're doing it in a testing environment so that we can look at that response and assert against it, check against it. Okay. Now, when it comes down to it, integration tests are really way more important than unit tests, especially in our backends, because we want to make sure our app is running as expected, right? And we want to make sure we're not saving corrupt data to the database, things like that. Remember that you can't, if we accidentally save corrupt data to the database, if we make a mistake with the database, it's really, really difficult, if not impossible, to reverse that. Right? You can't really reverse corrupted data in your database unless you have a backup database, which not all people have. So we have to be really, really careful. This is an image I like to show when talking about different types of testing. It's kind of morbid, but it's memorable. Unit testing only tests tiny self-contained pieces of the system, right? Like checking to make sure a light turns on and off, or that a door opens and closes, or that the rotor is spinning, right? Small self-contained pieces of the system. That's what unit testing checks for. But if the ship is sinking, then those small details don't really matter that much, right? It doesn't matter if we have some passing unit tests. If we don't have passing integration tests, then our ship could be sinking. So unlike unit testing, integration testing, it helps us to see if our ship is still afloat, which is really the most important thing. They give us an overall picture as to how our application is running, all right? So let's go ahead and write some integration tests. We're going to be working with Jest again, just as we did on Monday. So remember, it's just a test runner, and it can be used for different types of testing. So go ahead and open up the project, get your windows all situated. Now, by default, Jest is actually set up to work with browsers in the DOM. That's just its default configuration, which didn't matter much when we were writing our unit tests, but it might cause some problems now that we're writing integration tests. So we just have to go into the package.json and change some of the config for Jest as the first thing. So we're going to head into package.json and we're going to add another object just right after dependencies, and we're going to call it Jest. This allows us to customize Jest a little bit, to configure it. And we're just going to set the value of test environment, set that to node. That tells Jest that, hey, we're running these tests inside of a node environment rather than inside of a browser environment. So get that in there. Try running npm test, which is already set up. It just calls Jest. It's going to fail because we don't have any tests yet. So let's create a placeholder test just like we did on Monday so we can kind of get everything set up. Now, when we're creating test files, the best convention to keep is we write unit tests and we save unit tests right next to the file that they're testing, right? So if you're writing unit tests for calculator.js, your tests are going to go in a file that's right next to calculator.js called calculator.spec.js or calculator.test.js, right? That's a good convention for your unit tests. And then for our integration tests, it's best to keep them all together in a test folder. Okay, so we're going to create a new folder. And in the case of jest, it expects our test folder to be called underscore underscore tests underscore underscore. So 2 underscores at the beginning and the end of the folder name. That's just what jest expects. It's dependent on the test runner, so other test runners might look somewhere else. But in this case, this is where jest is going to look. So we have this tests folder, and then inside of that folder, we're going to create a file, and we're going to call it index.js. You don't have to append .spec or .test to this file because it's in a tests folder. And then once again, just do the same placeholder test that we did before, just to make sure that just will find this test. So we can just add a test, call it a placeholder test, give it a callback, and then we can just say expect 2 plus 2 to be 4. Just so we can be sure jest is finding this file. And then run npm test. All right, so it found that file. It just searched our entire project. It found the tests file, and then it ran all of the files inside that folder. All right, so this is a good start. This was a good start for our unit tests, since we could, at this point, we could just start importing functions and calling them and writing some assertions, right? But it's not quite enough for integration testing yet. We actually need a way to call our endpoints from a test. So we have to install a library that can do that, right? We would want to install maybe Axios or Fetch or some kind of library that could make HTTP requests from our test function itself. Now, in this case, we're going to install a library called supertest. So let's take a look at the supertest library by Vision Media. All this is, it's just a library that's similar to Axios, where it can make HTTP requests to a server, but it also has some built-in functionality for testing against the responses. So for checking status codes or checking response data or response headers, things like that. So let's go ahead and get this installed. Just npm install supertest and then save dev, since this is a dev dependency. And then go back into our test file and import it. So you can just get rid of the placeholder test, and let's say const supertest equals require supertest. And then since we're testing our endpoints, we actually need access to our server. So we're going to import our server by just saying const server equals require / index. Just import the index file. And then write your first integration test. I like to name my integration tests by the method and then the endpoint that we're calling. So I'll just say test get /. So we're making a get request to the home page. And then since this function is actually going to require waiting on promises, it's going to require some asynchronous code. we're going to mark our callback, test callback as async, so that we can call await inside of this function. And jest is actually built out asynchronously. So if our function, if our callback function for the test is async, then we don't actually have to have a try catch like we do in our route handlers. In this case, if one of our promises rejects, then jest will just throw an error automatically, which is exactly what we want, because then we'll see the error in our test. So we don't have to have try catch here. We just mark it as async. And then if you take a look at the supertest documentation, it's actually pretty straightforward. We just import it, and then we call supertest as a function. We pass our server, and then we can call .get with a route. You can call .post with a route, so on and so forth. And then you can either supply a callback with .end, or you can use await, and we're going to use await. So let's just assign this to a new variable, the response. I'm going to call it res, short for response. And then we're just going to call await supertest, call supertest as a function, pass the server. And then just like you do with Axios or any other HTTP library, we can just call .get and give it an endpoint. Now what that's going to do is it's going to make a request to that endpoint, just as Insomnia would do, and it's going to take all the data that comes back and store it in that res variable. So let's go ahead and just log that variable out, just so we can see what it looks like. So don't write any assertions yet. Let's just take a look at it. Try running npm test with what we have so far. All right, we get an error. We get a failing test. And it says app.address is not a function. Who knows why this isn't working quite yet? Any ideas? Specifically, take a look at the index file. We don't need to start the server, but we actually need to export the server, right? In this case, we're importing server and we're using it with supertest, but we're not actually exporting anything from index yet. We're defining the server and we're starting the server, but we're not exporting it. So remember, whenever you're importing something from another file, you have to make sure you export it. So down at the bottom of the index.js, we're going to say module.exports equals server. This is just how supertest works. It expects an instance of our server, and then behind the scenes, supertest is going to start the server, make the request, and close the server. Now there's still one more problem. If you were to run your test again, you may have even noticed it the first time. And that's the test runs, but it never closes. It just kind of hangs, right? That process closes and you might see this error that says just did not exit 1 second after the test run has completed. And this is due to one more issue in our index file. This is because the server is still running. It's still running and it's still listening for incoming connections, for incoming requests. Because if you remember, when we call server.listen, that means the server is going to run indefinitely, just listening for requests, right? It's never going to actually close that process unless we specifically stop it with Control-C. But when we're doing this in a testing environment, we don't actually want that server to run. We don't actually want it listening for incoming connections, because that's something that supertest does automatically. When we call an endpoint with supertest, what it's going to do in the background is it's going to start the server. It's going to listen on some random port. It's going to make the request, gather the response data, and then it's going to close the server so it's not still running. It does that whole thing automatically. So we actually don't need to specifically start the server when we're testing. So how could we prevent the server from actually starting, from actually listening when it's running within the context of an automated test? Any ideas? So Eric was a little bit ahead of me here. Eric says he usually splits the server config from the main index file. That would be one solution to this. You could move your server.listen code, move that into a different file, maybe call it server.js. Or opposite, you could move all of your middleware and all of your server definitions into another file, and then in index, you only have server.listen, right? And then inside of your test, you import server instead of index. I'm sure you've seen this several times in the training kit and in projects, so I won't demonstrate it. But that is one option here that would fix this hanging server. There's actually another way. In my preference, it's an easier way. You can do it however you want. But the way that I prefer is I just go into the index and I wrap the server.listen in an if statement. So you can say if module.parent is falsy, then go ahead and start the server. This is a special node variable that contains a value if this file is being imported into another file. So this is essentially saying if this index file, if it's being required into another file, don't actually start the server, right? Since that's something supertest is going to handle automatically for us behind the scenes. Otherwise, if this index file is just being run directly with Node, if it's not being required into something else, then go ahead and start the server like normal. So you can do that either way. You can have the if statement, or you can split out your server.listen into another file and do it that way. I'll leave that one up to you. But now we can run the test and it will properly close. Cool. All right, so far the only things we've done is we've created this index test file. We've added an integration test. We called supertest with the get root route. We logged out the result. And then we went into the index and we exported the server and we added this if statement around server.listen. Now go ahead and take a look at that object that got logged out when we ran our test. It's a huge, giant jumble of data. It's a really large object. But nestled in here, you're going to find some really, really useful things. You'll see that you get like the response headers that come from the server. You'll see that you get the response body that came from that request. You'll also find the status code in here somewhere. So now that we have this object, it's coming back from that request, we can write assertions against it, right? We can check for specific things to make sure that our endpoint is returning what it's supposed to return. So we usually want to consider 3 questions when we're asserting data from an endpoint. There's 3 things we need to check for. The first one is, does it return the expected status code? So if we call an endpoint and it's supposed to return a 200, we need to check for that in our assertion. Does it return a 201 when it's supposed to return a 201? Does it return a 404 if it's supposed to return a 404? We also want to check to see if it returns the expected data format. So most of the time we're going to be expecting JSON, right? So we want to make sure that our server is returning JSON. But maybe we're expecting HTML on a specific endpoint. We want to check for that data format. Or maybe you're working on an older system and you're working with XML. You want to check to make sure your endpoints are returning XML. Maybe you have some endpoints that return CSV. You want to check for that data format. But most of the time it's going to be JSON. And then we also want to check, does it return the expected data? Does our response data look right? Does it have all of the values that it's supposed to have? Does it have the ID? Does it have the correct message, the correct username, whatever is coming back in that response object? So let's write assertions for each one of these things in our test. So get rid of that console log and let's assert against the status code first. So let's just say expect res.statuscode .2b. And in this case, since it's just the root route, the expected status code should be 200. So make sure we get a 200. If we call that endpoint and we get anything other than a 200, throw an error. Don't let the test pass. All right, so we're checking the status code. Now we need to check the data format. How do we check the data format? What's a way that we can be sure that the data format is correct? That the response format is correct? How does the browser, for example, know how to render the response? Does it show an HTML page? Does it show a JSON object? How does it know? Good, Jennifer. It's the content type header. There's a specific header that comes back that's part of the HTTP spec that's called content type. And the content type should match whatever content is in the response. So if your content type is application/JSON, then your response data should be JSON data. If your content type header is text/HTML, then the response data should be HTML. So in this case, our response data should be JSON because we're sending back a JSON object. So let's write another assertion and let's say expect res.headers content type to be application/JSON, which is the data type for a JSON object. If you want to see what other content types there are, there's a whole bunch of them. If you're returning like audio files or images or videos or CSS, there's a whole bunch of different content types that you could potentially be returning. In this case, we're returning JSON, which if you scroll down, you'll see the content type for JSON is application/JSON. And last but not least, we need to check the response data itself. So let's just write another assertion. We'll say expect res.body, which gives us our response body. And since this is JSON, we can actually check the keys of the JSON object, which if you look at the response is just an object with the value of message, which is welcome to our API. So let's just check res.body.message. Expect that to be welcome to our API. And that's it. We're now checking for those three different things. Try running your test and see if it passes. And it fails. So this kind of goes beyond the depth of this lecture, but sometimes when you're defining a content type, you also have to define the character set. If you want to research character sets beyond this, feel free. They're pretty in depth. Most of the time, the character set that you're working with, since we speak English, is UTF-8. But say you're returning some JSON data that has Chinese in it, or some other, I don't know about Chinese, but some other language, it might not be supported by this character set. So you'd have to specify a different character set. And that's part of that content type header. So we can just copy that char set UTF-8 if your test is not passing, and just add that to your expected content type. Let's try running that again. Cool. So now our test passes. So a lot happened between running that test script and seeing this output. Think about it. We ran npm test, Jess went through and it found our test file. It ran the code inside, which means supertest booted up. Supertest took in the instance of our server. It made a GET request to /. It gathered up all that response data, put it in this variable, and then we were able to check against some different things on that response. And since everything matched, then it went ahead and passed the test. Try changing the text that the welcome endpoint returns. So come into here and change the message from welcome to our API. Try changing that to like hello or yo, or just change it to something so it doesn't say welcome to our API. And then run your test again. And you'll see it fails because it was expecting welcome to our API, but that's not what we got. We got something else. So now if one of our endpoints starts returning something that we're not expecting, if some bug gets introduced in our code that we don't realize and it starts returning something different, then we're going to get alerted about that. And it's going to say, hey, this doesn't look right. This endpoint is not returning what it's supposed to return. Go take a look at it and fix it if you need to. So now we've completely automated that whole process of going into Insomnia, creating a new endpoint, and manually testing it every single time we make a change. Right now we can just run npm test and boom, it's done. It checks everything. We can now write these tests for thousands of endpoints, right? There's no limit to the number of tests we can make here, and we can run them all at once with just that single command. So if a single endpoint in that set of 1,000 endpoints, if a single one stops working at any point in the future, we're going to know right away because our tests are going to start failing. Okay, that's the beauty of automated testing. Any questions so far? Robert, looks like your error is no tests found. So make sure you're naming the files correctly. Make sure you name the folder __ tests __ 2 underscores. Any other questions so far? What if we want to test an endpoint that accesses the database? Right now, this welcome endpoint, it doesn't really access any real data, right? It just returns a hard-coded string. But if we take a look at some of our other endpoints, I'm going to change that message back to welcome to our API so we have the passing test again. But take a look at the Hobbits folder and the Hobbits router. This is just an application that returns a list of Hobbits, or just has a database that's full of a few Hobbits, and it has an endpoint that lists them out. Let's create a test for this endpoint, which accesses the database, right? It's not just returning a hard-coded string, but it's actually doing a database lookup. So go back in your test file, and I'm going to use that describe format again, like we did on Monday. So I'm going to wrap this in a describe statement. And our describe, we can say Hobbits integration tests. And then put that test call inside of describe. You can rename test to it if you want to follow that convention. And let's write another test that calls get/hobbits and see if the database access works. So create another test. We'll call it get/hobbits. It'll be async again. And then just do the same thing with supertest. You're going to call supertest. You're going to call .get. Only this time instead of slash, it's going to be /hobbits. So we'll say const res equals await supertest. We'll pass the server to supertest, and then we'll call get/hobbits. Now, what should we put for our assertions? We want to check for the status code. First thing, you can just copy that from the one above because we're still checking for a 200. We're also expecting JSON data once again. So you can copy that same expect from the previous test because we're expecting application/JSON charset UTF-8 content type. What about the body? In this case, we're actually receiving an array of data. So how should we check for an array of data? We could check, maybe for one thing, check the length of the array, right? Maybe we want to check the length to make sure it's it has a certain number of items. We can check individual items in that array to make sure they match specific things. Let's do that. Let's say expect res.body, and let's use the assertion to have length. And if you looked at our database, we actually have 4 hobbits. So expect res.body to have length of 4. And then let's just check the first item in that array. Let's check the Hobbit name in the first item by just saying expect res.body at the index of 0.name. Expect that to be Sam. Now this is usually enough. This is usually what I do when we're checking against an array response, is you check for the length somehow, and then just check the first item, maybe the first and second item in the array, but you don't have to check every single item in the array. You just want to make sure it's returning an array of names, right? An array of hobbits. So now if we call this test, if we npm test once again, it should pass. Let's check it. And it passes. Our first test still passes. We still get the welcome message. And our second test passes. It's calling the hobbits endpoint, which is actually doing a database lookup, and it's getting data from the database. And those assertions pass. Yes, good thinking, Jennifer. And we will get to that in just a moment. Let's look at this first. We're still getting that weird warning again that says that the tests didn't exit after 1 second and the process hangs. And this is because of that database access, because we're now accessing the database. So before we were getting that when our server wasn't closing properly after the test. But now in this case, our database connection isn't closing properly after the test, which can be problematic. So we just have to manually close that database connection. If you didn't get that, great. Then you don't have to do this. But if you did get it, then come to the top of the test file. And we're going to use another one of those jest globals called after all. So call after all as a function. This is referred to as a hook. And all it does is it allows us to specify a callback function that runs after all of our tests are completed. So after it runs these two tests, it's going to run whatever code is in this function, which we can use to close that database connection. So to close the database connection, we're just going to import the db config. So we'll say const db equals require .. data / config. Same as you do when you make a database call or when you're accessing the database through Nix. And then we can just say inside of after all, inside of that callback, we can just say await db.destroy. And that will close that database connection after the testing is done. Once again, if your process did not hang, like Ashley, you probably don't need that. But since mine did, I'm going to add it. Now that it's added, I'll run npm test again. And the tests pass, and it properly closes. Perfect. All right, let's take a 5-minute break. See you when you come back. All right, come on back. Question from Slido. Do developers write and save test files every time when they write front end or back end? So if you're asking, do developers always write tests? No, they do not. And it's frustrating when they don't because you can't really trust their code as much. So that's why you should always write tests as a developer so that other developers, your teammates, your company can trust your code a lot more. How are we feeling so far? Any other questions before we move forward? All right, let's take the next 10 minutes and see if you can write a test and an endpoint for getting a single hobbit by its ID. All right, so use tester in development and create a new test for getting a single hobbit by the ID, and then create the supporting endpoint to make the test pass. Make sure you send a 404 if the hobbit doesn't exist. I'll give you until a little past 30 minutes, so I'll give you about 10 minutes. Go. So Ashley asked, in the after all, could you do server.destroy to eliminate the server staying running? Yeah, you could. In that case, I mean, there's really no point in starting the server if you're just going to stop it manually, because that's Supertest does that automatically. So yeah, you could. It wouldn't hurt anything, but it's kind of pointless. Give me the heavy metal horns on the post when you're done. If you're struggling as to how to make that database call, take note of the function inside of Hobbit's model. It's already written for you, called find by ID. You just need to call it with an ID. I'll give you about 5 more minutes. All right, try and wrap up here in the next minute or so. Yep, you do need to create the route, Robert. You got to create the route. You don't have to create the model function. You just have to create the route and call it model function. All right, go ahead and stop where you're at. Let's go through this. So test-driven development, we're going to create the test first, create the failing test first. So let's head into our test file. We're going to create another it function. This one is going to be get/hobbits/id, since we're getting a specific hobbit. Again, you can name them whatever you want. This is just how I like to name the tests, just so I know exactly what's being tested. We're going to make a super test request. So we'll say const res equals await super test. We're going to pass the server. And we're going to call .get/hobbits/some ID. There's 4 hobbits in the database, so we can say 1 to 4. Let's just select 2, the second hobbit. So we'll make a get request to /hobbits/2. We're expecting the status code to be 200, just like the other tests. And also we're expecting the content type to be JSON. So you can go ahead and just copy those assertions from the other tests. And now asserting against the data this time, we're not asserting against an array. It's just a flat object. It should just be a flat object. And it should have an ID field and a name field. You could have seen that if you went into the data folder and you looked at the migrations. You'll see that hobbits have an ID and a name. Or you also would have seen that if you looked in the seeds file, you'll see they have a name. So let's assert against both the ID and the name to make sure they both come back from this endpoint. So we'll say expect res.body.id to be 2 in this case. And we should expect the res.body.name to be Frodo. Again, you could have seen which hobbit that would have been. If you just looked at the seed data, you'll see that the second hobbit has a name of Frodo. So we can just throw that in there. So there's our test, currently failing. If we were to run our tests, failed, expected a 200, but we got a 404 because that endpoint does not exist yet. But now we know exactly what it should do. We know what it should return. So let's go make it do that. So we're going to head back over to the Hobbits router and let's make a new route. So we're going to say router.get, same endpoint that we're testing, which is /hobbits/id. Use a route parameter for the ID because we want that to be able to be anything, just some number. Give it our async request handler function. Oh, yes. Thanks, Jennifer. My mistake. In this case, since this router is using a prefix of hobbits, we don't have to redeclare hobbits. So we can just say /ID to the endpoint. Good catch. Get your try catch in there. Now, what do we need to call to actually look the hobbit up by its ID? Somebody throw it into Slack for me. Yep, we're going to get the value from request.params.id. What are we going to pass it to? Hobbits.findById. Good run. Good one. Luan and run. So let's say const hobbit equals await hobbits.findById. And we're going to pass request.params.id. So save that to a variable called hobbit. Now you could just pass this directly to res.json like Tarek showed in Slack. But in this case, we might not want to do that. Why not? What do you think, Tarek? Why is that? Why should we not pass it directly to res.json here? What was one thing we need to do in the requirements? If we're just looking this hobbit up by the ID, we need to make sure it exists before we try and send it back. If it doesn't exist, we need to return a 404 instead of a 200. So let's just write an if statement. We'll say if hobbit doesn't exist, then return a res.status with 404. Send back some JSON data with a message that says hobbit not found. But if there is a hobbit, if everything looks good, go ahead and just return it with res.json. Is that enough to make our test pass? Let's check. Nice. Indeed it does. Looks good. Still checking our original routes, still checking the welcome route, still checking the get hobbits route. So now it checks 3 endpoints every time we call npm test. What's another edge case that we could test for here, that we could write another test for? We wrote a test that checks to see if hobbit 2 exists, and we check against that response data, that response status code. Everything looks good there. But what else should we check for? What else should we check? Should we test for? Anything else you can think of? If we're striving for, what you want to do is you want to strive for 100% test coverage, which means all of the lines of code in your router should be covered by a test at some point or another. It's referred to as test coverage. And if we have 100% test coverage, then that means every single line in our endpoint is being tested. Right now, we don't. We don't have 100% test coverage because this huge block of code right here, this if statement, that's actually never triggered. It's never tested during our automated test because we never try to call a hobbit that doesn't exist. So let's write another test that checks for that, that specifically calls an endpoint with a hobbit ID that we know doesn't exist, just to make sure that it returns a 404. And that's going to give us a little bit more test coverage. So I'm going to write another test. This one is going to be forget/hobbits/ID. And then I'm just going to put in parentheses, not found. And then just copy those first 2 lines, those first 2 assertions from the previous test. Except this time, instead of calling a hobbit with an ID of 2, which we know exists, let's try calling a hobbit that doesn't exist, that we know doesn't exist, like 50, for example. And then instead of expecting the status code to be 200, we're expecting the status code to be 404. And then you can check the content type header again. So copy that line. And then check for the message by saying expect.res.body.message to be hobbit not found. Cool. So now if we call our tests again, we have an additional test that gives us a little bit more coverage. It's testing to see if that hobbit exists, but it's also trying to see if the 404 gets triggered, which it does. And we have a passing test. Nice. Let's do the same thing with a post endpoint. Let's write a test to make a post request with some data to create a hobbit. And then we'll write an endpoint to actually make it work. So far we've tested endpoints that just retrieve data from the database. But let's make another one that actually creates data in the database. All right, so in that same describe block, we're going to make another test. This one is going to be post/hobbits. We're going to do the same thing. We're going to say const res equals await supertest server. Only this time, instead of .get, we're going to say .post. And we're going to post to /hobbits. And now, since this is a post endpoint, it's going to expect some data. It's going to expect some request data to be sent, right? Some JSON with some data for the new hobbit, the name. So in order to send data with a supertest request, all we do is we go after the .post. I'm going to put it on a new line just so it's more readable. After .post, and we're going to say .send. And we're going to send an object. And inside of that object, we're going to say name and give your new hobbit a name. Now, what status code should this endpoint return when we implement it? Good. I should return a 201 instead of a 200. So let's expect the status code on this endpoint to be 201. Copy your headers, your header check, your content type check. And what should this endpoint return? What kind of response data should it return with? Maybe just the data for the new hobbit, the ID and the name, right? So let's check for the ID. Let's expect res.body.id. But what do we compare it to? We don't know what the ID is going to be exactly. What do we compare that to? Well, we could just check that it's not undefined. Just check to make sure that it's something, right? That it's not undefined. Which I believe in jest, we can just say to not be undefined. I think that's the right function. Let me double check that. Oh, nope, I'm incorrect there. It's not to not be undefined. It's to be defined. So expect res.body.id to be defined. Make sure it's not empty. And then just expect res.body.name to be Bilbo, or whatever you put for your new Hobbit name. I would highly recommend you go into the jest documentation at some point and just read through all of the different assertions you can do. There's a whole bunch of them. To be defined, to be, to equal, to be length, to be greater than, to be less than, to match, if you want to check against a regular expression. There's a lot of different ones that you can use. All right, so that test should be failing. All right, so let's make it pass. We're going to create a new endpoint, router.post. The route is just going to be slash, because remember we have a prefix on this router, which is hobbits. And then if you look at the model, the function we need to call is create. We call create and we pass through some data. And then it just returns, it already returns the find by ID, looking up based on the new ID. So we can just say const hobbit equals await hobbits dot create. I'm going to send through request.body. And then just send that back to the response by saying res status of 201, since we're creating a resource, .json, and send hobbit. All right, run that, and our test should pass. Indeed, it does. But try to run it again. And it fails. Interesting. So our test passed the first time we ran it, but then it failed the second time we ran it. With the message of in the get hobbits test, we're expecting a length of 4, but now we're getting a length of 5 since we got a new one. So this test made one of our previous tests fail. So we have two options here. We could go back to that first test. We could change it. So when we're calling to have length 4, we could change that to 5. and then it'll pass again. But then if we run it again, then it's going to fail again, because then the count is going to be at 6. We run it again, that's going to be at 7. We'll have to keep changing that over and over and over again, and it will be a pain. So we could change that assertion from to have length 4. We could change that to something like to be greater than 4, greater than or equal to 4. But there's something else that we could do that might be a little bit better rather than changing that assertion. If we leave that assertion at to have length 4, something we could do is we could reset the database each time a test changes something. What can we use? What have we used in the past to reset our database to the initial data? You remember? How do we reset our database? We reseed it, right? Remember our seeds? Anytime we reseed our database, it clears it out and puts new data in there, resets it to the initial data. So we can run the seeds by using that CLI command. If you remember, we can come in here and say npx next seed : run, and that'll reseed it. And we could just do that every time we run our tests. Or we can run those seeds programmatically, right in our test file. This is something that I do a lot. This isn't it's not in the training kit, but I think it's really good to know. If we create another hook, this time if we say before each, which is a jest hook that we can run before each individual test. So anytime it comes to run a new test, it's going to run the code inside of before each, which we can then use to just reseed our database by just calling await db.seed.run. So now when we run npm test, Jest is going to come through and it's going to run the welcome route test. And then it's going to reseed the database and it's going to run the get hobbits test. And then it's going to reseed the database and it's going to run the next test and it's going to reseed and the next test, and reseed, and the next test. So each individual test is now going to have its own fresh database to test against every single time, which makes our tests way more predictable and way easier to write. Okay. So let's go ahead and try running those tests now. Oop, not seed. We run npm test. Everything passes. Cool. Run npm test again. Everything passes. So now we can run it as many times as we want. Each test has a fresh copy of the database to work with. And we don't have to change our assertions in other libraries as stuff gets added to the database. Really, really handy. Yeah, they do have the before each hook in the training kit, but they don't have the await seed run, programmatically running the seeds. That's something that you can find if you dig through the documentation of Nex on how to run these seeds programmatically. It's important to know that you can do that though. All right, let's take another 5-minute break. I'll see you when you come back. All right, come on back. How's everyone feeling? We have one more thing to cover before we close out the night. So now that we're constantly reseeding the database, something we might want to consider is using a test database, a separate database that we can keep separate from our primary database. Something that's only used in automated testing, right? So we can keep our other database untouched, which could potentially have maybe real data in it, real live data. So we wouldn't want to constantly be clearing it out. Right? It might make sense to have some kind of a test database, a separate database. Now, if you look at the next file in the project, you'll see that we're connecting to a database file called hobbits.db3 in the data folder. That's our actual database location. If we wanted to use a different database, say like a test database when we're running through Jest, we'd have to specify a different file, which we can do in Nex using environments. Not environment variables, but different environments here. And we can specify environments. You might have seen this in some of the projects, but you can just specify an object, say like development, and then inside of development is where you have your development configuration. Right, and then you'd make another environment, maybe it's called testing. And inside of your testing configuration, you can copy everything that's in development, but change the file. So instead of hobbits.db3, it could be test.db3. So we can set up all different kinds of environments for Nex, and they can all connect to different databases. And this allows us to keep things kind of separate. So go ahead and get those two environments set up in the Nex file. Development and testing. We're going to change the testing database to test.db3 instead of hobbits.db3. Save it. And then we're going to go to the terminal. And if we wanted to run our migration command, for example, well, before what we would do is we would just call npx next migrate : latest, right? And that would migrate to the latest migration. But now what we can do is instead of just calling migrate latest like that, we can specify --env equals testing. And that's going to run the migration command for the testing environment, for the test database. I'm not sure what those warnings mean. Just ignore those for now if you see those. But it actually, if you look at the code, if you look at the code editor, you'll see it creates a test.db3 file right next to hobbits.db3. So now we have two databases to work from. Let's say you wanted to seed the test database. We could do the same thing with our seed command. So npx next seed : run --env equals testing. And that'll run the seed command for our testing database. So now anytime we run a next command, we specify which database to connect to, which environment to run in based on that --env argument. Now it's easy enough to specify that environment flag when we're running next commands from the terminal. But what about when our app is running? When our actual app is running, when the server is running, it's not going to know whether it should connect to the Hobbits database or the test database. If you look at our data config file, just data/config, you'll see that we're just passing the entire next file, just the entire next instance, or the entire next file config into the next instance. We're not specifying an environment here. So if we wanted the development environment, for example, we would say nextfile.development. And that would give us the development config. If we wanted the testing config, then we would say nextfile.testing. Right, so now we can specify an environment to use when our server is actually running. But what's the problem with doing it this way? If we were to just say nextfile.development, save that, and then we went and start our server, it connects to the development database when we're running our server. But when we run our tests with Jest, it's still going to connect to the development environment. It's still going to just do the same thing. Right, so how can we tell Jest to use the testing database, and then we tell our app to use the development database when it's not using Jest, when it's not testing? Think back to some of our previous lectures. How do we change the functionality of our application based on the environment? Environment variables, right? What if we set an environment variable to determine which database to connect to? And that way we could change it between running through Jest and running through Node. Now we could use .env like we've been doing before, but I'm going to show you a different way. We're going to take a look at a library called crossenv. Crossenv is it's a library that allows us to set environment variables just in line with the script. And it works cross-platform. So whether you're on Windows or Linux or Mac, it's still going to work. And you'll see how we use it. We just go to our npm script, and before we call the actual script, so it says Webpack in the documentation, but that would be Jest in this case, or Node or Nodemon. We just prefix crossenv, and then we give some environment variables. And that'll allow us to set a different environment variable for each npm script, and thus allow us to connect to different databases depending on where it's getting run from. So let's go ahead and install crossenv. This is a dev dependency. And then we're going to go to the package.json where we define those npm scripts. We define test and server and start. Now, instead of saying test Jest, we can set an environment variable by saying crossenv. Let's say node env equals testing, and then call Jest. Now, when we run npm server or npm start, those are going to be running in potentially different environments, right? We want those to connect to different databases. So let's do the same thing. We'll specify crossenv before the commands, but we're going to change node env to something else. So for server, change node env to development. For start, you might want your environment to be production. Right, we haven't specified a next environment for production, but now you could if you wanted to. So now that we're setting that environment variable, if we were to go back into the database config, how would we use that environment variable? Right, now we're just calling nextfile.development, but now we want to change that environment, change the database that we're connecting to based on this environment variable. How do we do that? Yep, we want to use the node-env environment variable. Now, if you haven't done this before, you can look up a value in an object using a variable as the key name if it's wrapped in square brackets. So now instead of saying nextfile.development, we could say nextfile brackets, and then inside of brackets, we can say process.env.nodeenv. Keep in mind, it doesn't have to be node-env. That doesn't have to be the environment variable name. That's just what we're doing. You could name that next environment or database environment, whatever you want, as long as it matches up between the time you set it and the time you use it. So now if we run npm test, node-env is going to be testing, which means we're going to use the testing environment from the next file, which means we're going to connect to the test database. If we run npm server, then node-env is going to be development. We're going to use the development key of the next file, which means we'll use the hobbits.db3 file. If we run npm start, node-env is going to be production. It's going to try to connect to the next file environment of production, which actually doesn't exist yet. So you'd have to come into the next file and you'd have to create another environment for production. Whatever that may be. Okay. Any questions about that? Now, if we go into Jest, or if we go into the terminal and we run npm test, all of these tests are all running against the test database. And if we run npm run server, we're now connected to the Hobbits database. All right, that is it. You have now made it through the backend curriculum. Congratulations. You're going to learn some really helpful things in the computer science block, things like algorithms and data structures. But in the meantime, some of the next steps from this point would be to maybe to go learn other backend languages. Maybe you're going to go learn Go or Ruby or Elixir or some other backend language, Python. You're also going to want to learn how to interact with other types of databases, things like Postgres, MongoDB, Redis. But really the biggest thing you're going to want to do is just keep practicing, right? Just keep practicing, keep building things. Like I promised, I'll give you a list of links and resources at the end of the week after your sprint challenge that'll hopefully send you in the right direction for learning more backend stuff. So keep an eye out for that. Yep, I will post all this code. Since we have some time, I want to open it up to you now. If you have any questions about the material we've covered over the past month and a half, or what it's like to work as a backend developer, or just whatever is on your mind, feel free to type it into Slack, Slido, or unmute your mic and ask it in person. Let me stop the recording real quick.